I just start the recording. So we have two types of files in C language, according to depending on how to access the data in this file: random access file and sequential access file. So inshallah, today we will speak about introduction of the files and some information about files. Then we will speak about the sequential access file and give some examples about sequential access file. So first, until now, we take from the beginning of this semester many subjects, as we know how to use strings, recursion functions, dynamic memory allocation, linked structure, and linked list. But so far, until now, when we close the program, we lose all the data that we used in our program. Maybe you saw this in a linked list. Every time we need to create the linked list and start to make some operation. Okay, but what about if I want to keep this data? I need this data. I want to keep this data. For example, if I have a system to keep student information or to store student information, so how to keep or store this information? Actually, we need files to do these things, because without files, when you use variables, linked lists, structs only to store this data, it will be only temporary, because variables or struct or linked list, it will be implemented in RAM memory, random access memory, or in another term, it's temporary memory. So you close the program, you will lose the data. That's why in most programming language, or all programming language, give you the facility to keep your data in files. Also C allow you to create, update, and process files, and these files will keep or store the data in permanent storage, so like hard disk or pen drive or any permanent storage, so you can keep your data for next run of your for your program. About files in C view file as a sequence of bytes. So maybe you can open any file and read it, but C language view this file as a sequence of bytes. Byte 0, byte 1, byte 2, until the end of the file. So to identify the end of the file, there is a marker or a special byte to tell C that this is the end of the file. So file end have end of file marker, which is a special or specified byte, and this byte depend on operating system, type of the system, we will see the different type of this end of file marker. Okay, so we can create file, view the file as a sequence of bytes. The meaning of sequence of byte, it do not know the data type inside, or if you have record that we have one record, second record, and so on. No, it see or view each file as a sequence of bytes. You as a programmer need to know what type of data inside this file. We will see this by example. Okay, about data hierarchy, small type or smallest type of data is byte. Byte is the smallest data item, its value 0 or 1. Okay, bit, sorry. Byte, it's 8-bit. It's used to store one character or one digit of other type of data types, like the decimal or letters from the string, each letter one byte, or a special symbol. Okay, then we have byte, bit, byte, then field. Field, it's a group of characters or group of bytes that give you meaning, conveying a meaning or convey meaning. Like, for example, your name, your ID, your address, your gender, and so on. This is a fields. Group of related fields give you the record. So record, it's a group of related fields. The meaning of related, it's about one object. For example, student, we have student number, we have student name. Each one is a field, but all fields is related information to a student. So we said this student record, student Ahmad record, student Mahmoud record, student Omar record, student Ali record, and so on. Okay, so we usually build records or represent records as a struct. I think we already take struct for 3 weeks. Okay, we take a struct, then we take a struct as a linked list for another 2 weeks. Okay, then a group of related records confirm file. So file consists of a group of related records. For example, we have file for the students. File for the students, it will have records for each student. Okay. Also, we have database. Database, group of related files. For example, if we speak about database for university, we have files of students, files for teachers or doctors or academic staff, file for courses, to keep courses information. And we have that, we know that this teacher or this doctor teach this course, and student take this course, and so on. So we have students file, have students record, we have teachers file, have teachers record, teacher Ahmed, teacher Mahmoud, and so on. And courses, we have programming 1, programming 2, and so on. So each file or group of these files that related to each other have relation, confirm the or give you the database. Okay, so the smallest things that we have, byte or bit, sorry, bit, then a group of bit give you byte, then a group of byte give you field, which usually have meaning, okay? And the group of fields, first name, last name, address, and so on, give you record. A group of related record give you the file, and the group of related file give you the database. Okay, then we will speak about the files, which is a group of related records. But as we see, or as we know that C views each file as a sequence of bytes. But we need to store records inside this file. So you as a programmer should know how to store records and how to return records from files, because C language cannot view file as a group of related records. It's a view file as a sequence of bytes. Okay, so type of files in C. We have two types of file depending on the access method or the way of the accessing the data. We have sequential file and we have random access file. Sequential file, the data is kept in a sequential order. Okay, data kept in a sequential order. If you want, this means if you want to read, for example, last record, you have to start from the beginning and read all record before it. So in the sequential file, every time you want to start from the beginning of the file until you reach the place or the record that you need. Of course, this will take more time. Take time because if you want to reach the last record, then you will start the first record and read all records from the beginning until you reach the last record. Random access file. In this type of files, you can read and modify the data randomly. This means you can read any record. For example, if you want to read last record, you can directly go to last record. Thus, this type of or this way for accessing file will take less time comparing with sequential access file. And it's have many advantage comparing with sequential access file. We will take today's only the sequential file, and inshallah next week we will speak about random access file, because also we need to understand the sequential access file to understand how to use the files. Then we can use the random access file. The difference is not too much for how to use the files. Okay. Also, we have two types of files depending on the type of data, how to store the data. There's two ways to store the data. You can store the data as character coded or ASCII character, or as binary format. So we have two types of data depending on the way to store the data, not accessing. Here we speak about the method for accessing the data. Here, the way to store the data. We can store data as text file, or binary file. For text file, it's usually the normal text file. It could be .text or anything else. You can use .c, data, anything, my name Nihad, anything. But the data inside this file will be text or character coded data, and anyone could use, for example, any text editor like Notepad or any editor to write data or to delete data or to modify the data. So the content of the file is stored as plain text, and you can easily edit or delete the content. Of course, it will take minimum effort for maintain, and you can read it, you can change it. But if the data important and it should be secure, this will not help you, the text files, because it's low security. Anyone can read it, anyone can change it, anyone can remove or change the data, so it have low security. Also, it take bigger space storage than binary files. In the binary files, the data will be stored as a binary form, which this means zeros and ones. Usually the file will be .bn, but you can use any extension for your file, but usually we use .pen. Like in text file, we use extension .text. But the data in the text file will be plain text, and data in binary file will be in the form of binary, zeros and ones. It have advantage that you can store higher amount of data than text file. Also, it's not readable for humans, I mean. So it will provide you with better security than text files. today, of course, we will take sequential files, so we will focus about text file and sequential file. Inshallah, next week we will take random access file, which will usually use the type of binary files. Okay, what operation we can do on the files? You can create a new file, you can open an existing file, and it's better to close the file correctly and read or write information to the file. So we have to know how to create the file, how to open an existing file, how to close the file, and how to read or write information to the file. Okay. First step to work with the files, doesn't matter what the type of this file. Is it sequential or random access file? Is it text file or binary file? First step, you should declare a pointer for this file, because we will use this pointer as the name of the file, and we will use this pointer to change anything with the file and do any operation for our file data. We will use the pointer for the file. So to declare pointer, you will specify the name of the pointer, and you have to use this star to set this pointer. So you have this sign for pointer, you have the pointer name that you will give for the pointer, and we have the keyword file. File is the data type file. So we define pointer, its name fptr, from type pointer for file. And we know that C language case sensitive file should be all capital letter like this. F-I-L-E capital letter all. Okay, so first step, we have to declare a pointer of type file. Okay. So how to open the file? To open the file for create or edit, okay, we use the function fopen. So to open the file, first step, we have to declare pointer. Then we will use function fopen to open the file. And this fopen defined in the library or the header file stdio or studio. Okay, actually studio mean standard, std standard io, input output, standard input output library. So any standard input output function, you will find it in stdio or studio. Okay, so what's the syntax? Our pointer of the file equal fopen, then file name with the path of the file. If you have the file in another directory, you have to name the path also of the file. But if you have your file at the same directory of your program, then you don't need to name the path also, only the file. And mod. Meaning of mod, we are opening this file. Why? We can open file for writing only, for reading only, or for reading and writing. We have to here identify or specify what the mod, why we are opening this file. So example here for opening text file and example for opening binary file. Here this only the path. So if file in the same directory, you don't need to mention the full path. Only you can mention the file name. So in first example, we have a file name new program.txt. Okay, if this file, we are opening this file for W. What's the meaning of W? For writing. So we are opening this file for writing. If we are opening this file for writing, and for example, this file does not exist, then the function will create a new file. But if you open it for read and it's not exist, the function will return null. Then if you check that the return value null, you know that the file not exist. Then how to read the file? But if you write, if W, this mean if the mod W, this mean you want to write in the file. If it's not exist in the directory or in the position, it will create a new file. So you don't need to say I'm creating a new file. If it's if the file not exist, then it will create a new file with the name that you specified here. New program.txt, my name.txt, student.txt, employee.txt or .data, anything. Okay. And then it will open it for writing. Why for writing? Because we mentioned the mod W. Then the writing mode will allow you to create and edit. If the file already exists, then you are opening it for edit. But you have to know that in a sequential file, when you open the file for edit, this means you are overwriting the existing content. So when you open the file for edit, you are overwriting the data. Then its old content will be overwritten with the new content. And this is a problem also. If you open it for writing and there exists information inside it, it will be a problem for you. So you have to focus which mode you will use. We will see different modes and each mode have different use. So about the mode, it's important to know which mode you are using. If writing, this means you are creating a new file. Even if the file exists, you are overwriting the old data in the file with the new data. Okay, so this means W means creating a new file. Even if it exists, you will delete the old data or overwrite the old data with the new data. Okay. For the second example, it's used mod RB, R meaning write, B because it's a binary file. So it's a binary file and we need to open this file for reading. If the file not exists, it will return null because we are opening it for reading. So you check if this return null, fopen return null, then the file not exists. Okay, if the file already found it, if the file exists, then you are opening it for reading, only for reading. If you try to write information on it, it will not write. Why? Because you opened it only for reading. Then you cannot write into the file if you opened it for reading. You can open it for write. It will be, if you open it W, then you are creating file or overwrite old file. Okay, then we have many modes. We have many modes for opening the file. Okay, with the function open, we have many modes. We have R for opening the file for reading only. If not exists, this will return null. So you have to check what's the return value from fopen. If you found it null, then you will set for the user the file not exist. RB same, you will find RRB, WWB, AAB. You just imagine it RWAB because it's the same, but the different here. R for text file, RB for binary file, W for text file, WP for binary file. So let us just focus on one of them and the other one will be same. So if you opening the file for writing, then if the file exists, its content will be overwritten. So it's like creating a new file. Even the file already exists, it will be overwritten. So it's like creating a new file. If the file not exist, create it. If the file exists, overwrite it. Okay. WB same for binary files. So A, it's open the file for append data. So you are appended data at the end of the file. So this one, if you want to add data to existed file. Add data where? To the end of the file. No, my mouse. Okay. So if the file does not exist, you will create a new file. If the file exists, you will add the data at the end of the file. So if the file not exists, it will create a new file. If the file exists, you will add data to the end of the file. Okay, we have also R plus. R plus, it's opening the file for reading and writing. Okay, opening the file for reading and writing. If the file not exists, if open will return null. If the file exists, then it will be read or overwritten. We will see the difference. Okay. W plus opens the file for reading and writing also. If the file, R plus, if the file not exists, will return null. If the file exists, then you are reading it. But W plus, if the file not exists, it will create it. This is the main difference here. For R plus, you will not create the file if not exists. It will return null. But for W plus, it have read and write for the file. But if the file not exists, you will create a new file. If the file exists, you will overwrite the file if you write a new data. If you read the data, okay. If you write, you will overwrite it. So we will see the difference between W and W plus, R and R plus. Next slide, inshallah. A plus also for appending and reading. So if the file not exists, create it. Okay. Just one term. Truncate, this mean overwrite. Okay. So you will delete the old data and write the new data. This term, truncate. It's same like overwrite. To see the difference between R plus, W plus, you can understand the difference from here. Opening file, you need to know for what. If for reading, then you use R, and it will be started from the beginning for reading. So you will start from the beginning of the file. Of course, here we speak about sequential access because random access have different way. Okay. If you open the file for writing, you need to know we will write a new file or we want to append data for the file. If you want to truncate, this means overwrite the existing data. Then you will use W. So you will ask for writing, okay. You want to truncate? Yes, then use W to overwrite. Okay. No, you don't want to truncate. This means you want to write to the end of the file, or you want to write more data, add more data, then you will use A. This means you will start at the end of the file and then write after the end of the file. Okay. If you want to open for read and write, and I don't advise this, it's better to open it for read, then close it and open it for write, or open it for write, then after finish, close it and open it for read. It will be better for you and to avoid the problem with read and write and overwrite the data. So to avoid the problem, it's better to know read or write only. But if you want to use this, I want to open for read and write at the same time, you have three choices. First, you need to know, I want to truncate or not. If you want to truncate, this means overwrite the existing data, then you can use W+. This allows you to read existing data and to write new data, but this new data will overwrite the old data. If no, this means you want to read and write, but you don't want to truncate. What's the initial position? You want to read from the beginning or from the end. If you want to start from the beginning of the file, then you use R+. If you want to start from the end of the file to write or to read, then you can use A+. Of course, if you use R+, you can write, but you will start writing from the beginning. So it will overwrite the beginning of the file, but you will keep the other data. So you can change here data at the beginning, then you will have a problem inside the file. That's why I advise not to use, I advise, but you can use the read and writing, but it's better from my point of view to use reading separately or writing separately. If you want to write a new one, use W. If you want to write data to existing one without losing previous data, you will use A. If you want only to read data, then use R. This for sequential file, as I mentioned. But about random access file, because all these slides speak about sequential file. For random access file, we have a different way and different ideas. We will speak about it. We will avoid all this problem about sequential file when we use random access file. Okay. Closing the file, we use if close to close the file. And it's good practice to close the file after using it, so you avoid any wrong closing for the file, which will cause sometimes losing data from the file. So it's better to close your file correctly. So the file should be closed after reading and writing. To close the file, you use fclose and the name of the pointer for our file. Okay. When you open a file, the system or the operating system will create a stream for this file. The meaning of this stream, the operating system will provide communication channel between the file and the program, or in another term, the file and the input output. Okay. We have three types of pointer. We usually use three type of pointer. This name, it's a standard name in C, so you can use this name. stdn, it's come from a standard input. So the standard input, usually the keyboard, standard output, which is the screen, and the standard error. This means standard output for the error, which is the screen. So if you use stdin, this means read from the keyboard. If you use std out, this means write to the screen. If you use std err, then this means you will write to the screen. How to use them and why we will use this type of streams, we will see by examples. Okay, we will see using for this streams in example. So opening a file will return a pointer. Also, we can use this pointer, or we can use this streams. We will see the examples, I think, after 2 slides. Okay, yes, after 2 slides. Okay, first, we have function for read and write information from and into the file. The standard input output, which is in the library studio.h for read and write. We have function if get c, if put c, if get s, if put s, and if scan if print if. We will use this one, but we will know the other types. I prefer to use last one, if scan if and if print if, because we familiar with similar function. Okay, let's speak about if get c. If get c, this means get character from file. So read one character from the file. So we are reading character by character from this file. It will take file pointer as argument, and it's equivalent or similar like get character. So you can use like this, if get character and your file pointer, for example, ptr. This means read one character from the file. Or you can use if get c and the standard stream, which is stdin. This means read one character from the screen, the keyboard, sorry, keyboard. So to read one character from the file, we give the file pointer for this function, and to read from the keyboard one character, we give the stream of the keyboard for this function. Same thing for if put c. You can write one character to the file or to the screen. To write to the file, you give the file pointer. To write to the screen, you give the screen stream pointer. So you can use f put c and your pointer for your file, for example, ptr. This will write one character to your file, or you can use if put c and sorry, you need to put the character, for example, A, B, any character. Then, or on the screen, you can put C, then the character, for example, H. I want to write H on the screen. So, comma, the screen stream, which is std out. So this is different. You can put the pointer for the file or the pointer for the stream. And you have two streams, three streams. Standard input, which is the keyboard, standard output, which is the screen, and the standard error output, which is the screen also. Okay, we don't use usually if get C or if put C. Even if get S and if put S, we don't use them really in real life. Why? Because we usually have the data in the file as records. So we need to read and write records. We don't need to read and write only one character or only one string. So this will read line by line from the file, or string by string, f get s and f put s. But the most famous will be if scanf and if printf. It's very similar. It's equivalent to scanf and printf. We know to use printf to print on the screen. We know scanf to read from the keyboard. So we are familiar with these two functions. These two functions, if printf and if scanf, same idea, same way of use, only we have one parameter added to it, which is the file pointer. So we have like this. For scanf, you usually define the data type and the variable. If you want to use if scanf, same thing, data type and variable, but you will add at the beginning the pointer of the file to see to say that I'm reading from the file, for example, ptr. Same way for printf. First argument for printf, you have to define the pointer of the file. We will see this by example. Okay, in this example, we will create a sequential file. This sequential file, we will put record for account of user, account balance for some user. We have account ID, name for the client. We speak almost for bank here. We have the account number for the client. We have the name, which is a string, and we have balance, how much money in the account. Okay, so we define the three variables. Now we will open, or we will define first the pointer, CF pointer, this pointer from the type file. Okay, then after that we will open the file. This will open the file. We are opening the file. Then to open the file, we mention the pointer fopen, then name of the file, then mod. Okay, then name and mod. We use here mod W. Why? Because we are creating a new sequential file. So we use W. This means if the file exists, it will be opened for writing and the content will be overwrite. If the file not exist, it will create a new file. Why then we check null? Because fopen will return null if it could not create the file. If we could not create the file, we could not create the file. Why could we do this? For example, if you don't have permission to create file on this directory, or I don't know, anything depending on operating system prevent you to create file in this position or something like this. If the file not created or existing file not found and cannot create a new file, then it will return null. Else, we did not have any problem. We open existing file or create a new file. Now we asking the user to enter data, enter account number, name, and balance. And we just read the data into this variables. So we read data to the variables. Then we put this variables data in the file. So after reading the data from the screen using scanf, normal scanf, we want to put this data into the file. How to write data to the file? Like printing data on the screen, we use printf, yes? So to print this data inside the file, we use printf. Same function like printf, but we have printf. Printf, same like printf. You see this part and this part, same like printf. Only we have one extra thing, the pointer for the variable, which is first term. Okay, so from here until the end, it's same like printf. We know how to use printf. The only addition at the beginning, we mention the pointer for the file. So this one means write or print inside the file. Okay. Okay, we return here. What's this meaning? This meaning keep while keep doing something until end of the file. Okay, we have a new function. F E O F. What's the meaning of F E O F? This meaning, the meaning of this one, it will take end of the file. Okay. And end of the file, as we mentioned here, I will return you to the first slide. Okay. End of the file. It's a marker or it's a specified byte. What byte? So every end of the file have a marker, which is a special byte. Actually, this special byte depend on operating system or type of the computer system. If you have, it's mentioned here, if you have Unix system, you need to print, to enter return control plus D. Return plus control plus D. If you have IBM PC or compatibles PC, like most of our PCs, Windows operating system, Linux, not Unix, Linux operating system, all exist in IBM PC and compatible PCs. So you will use as the end of the file Control plus Z. So if you press Control plus Z, this means end of the file. End of the file marker. For Macintosh or Mac, people, it's famous by Mac, okay, Control plus D. So, okay, what this mean? While, repeat, this mean while, repeat, until, or until this one not correct. What we check? If not, end of the file, read end of the file from stdin. What is stdin? It's the keyboard. Then we are waiting the user to write or to enter the end of the file. Okay. Why? Because SDDN means the keyboard. So we check the values entered from the keyboard. If it's end of the file, which is in my computer, Control Z. If you are using Mac, then it's Control D. If you are using Windows or Linux, it will be Control Z. Okay, so if this means if the user pressed Control Z, we finished because we reached the end. If not, why? That's why we are using not. If not, then continue to write data inside the file. So this meaning continue adding data to the file until the user enter or give me end of the file marker. If give me end of the file marker, then we finish entering data to the file. So this first record, we already read it before the while. So that's why we write it to the file. This writing or printing this data inside the file. From where brings this data? Not from the screen, because printf will get the data from the variables. These variables we already read it here using scanf, and then we write it into the file. Now it's only printing question mark like this on the screen, like we asking the user to enter new data or not. Okay, it's only message on the screen, and we read the variable another time. We read the variable, we return, go here and write the data into the file. We keep like this, read and write until we read, then the user give end of the file, come here, we give an end of the file, then finish, close the file. So let me run this code. Okay, then we have 3 variables. We have pointer. Okay, then we check if the file opened or created or not. If not, then error message, print to the screen. Okay, else please give me the account information. Until we did not reach the end, write this information into the file. Then you need more information. If yes, he will enter more information and we would write it again. If not, he have to press Ctrl Z. Then it's end of reading, close the file. Okay, let me here ask me to put data, for example, 300. You can use a space between each variable, or you can use enter. It's okay. So I can write like this: 300 Ali and balance 4,000. Press enter the next one, or you can write like this: 400 Ahmed, enter between each one, each variable. It's similar. Okay, we can write another one: 100 account number and name Nihad, and balance, for example, 3,000. Enter. I want to finish, then I will press Ctrl Z, then enter. This means finish the data entry. Okay, I already opened this one, client.data. I don't need to mention the path because it's at the same folder. So this client data, this Ali, Ahmad, and Nihad. Okay. So after finish, hit Ctrl plus Z, which means the end of the file, then enter key from the keyboard. Okay, then to create a sequential file, we already take the example here. To create the sequential file, you need pointer, then you need to use fopenf with the mod W, because we speak about creating a new file. So if the file exists, it will overwrite it. If not exists, it will create a new file. So even if I run this another time and enter new data, it will overwrite this. Let's check this one. Okay, I want to enter new data. For example, 600 GGG and 5,000. This enough. Control Z. You see the new data here. Okay, so it's overwrite the existing data. Okay, fprintf. So to create sequential file, you need a pointer. You need to open the file. You need to use fprintf to write data into the file. You need to check the end of the file pointer. Then you need to close the file. Another thing, you could use one file in your program, or if you want to use many files. If you want to use many files, each file should have unique name to differentiate between the files. You need unique name, and you should have different pointer. Each file should have its own pointer. So if you opening 3 files, you will have 3 declaration for the file pointer. Maybe you can name them BTR1, BTR2, or the name of the file, or something like this. Okay, for example, BTR student, BTR teachers, BTR. Okay, so it's better to have, or you should have different pointer for different files. If in the same program, I mean. Okay, until now we speak about creating sequential access file. What about reading data from a sequential access file? To read data, same idea. You need to declare pointer. You need to use fopen with the mode R. This means open the file for reading. Then you will use fscanf to read data from the file. It's very similar to scanf, except one added thing, pointer for your file. This part, if you check from here until the end, this means read variable account from type number, read variable name from type string, read variable balance from type float or from type double, and so on. Okay, so you need variables to get the data from the file. You need the name of the file pointer, and this part as any normal scanf, and this only the new part that you need to write the pointer name. Okay. In the files, you have a pointer, which is the file position pointer. Actually, this file position pointer indicate the next byte that you are going to read it. So if you have file like this file have bytes 0, 1, 2, 3, and so on. So if you read this part, the pointer will point to the next part, and so on. Read this part, then the pointer will reach this part. So it will give you the position, next position, which is a byte. If you are at the beginning, then it will give you 0 byte. So it's not really a pointer like pointers in the memory. Pointer for the file position, it's not pointer like pointers in the memory. it's actually the byte offset or the byte number. That's the pointer stop in it. I stopped here in 4, then the byte offset or the pointer will be 0, will be 4. If I stop at the beginning, it will be 0. If I stopped here, it will be 3, and so on, depending on the size of the record that you read or write every time. In the reading, we can use also, or in the writing also, we can use function rewind. Rewind means this position pointer will be repositioned to the first byte, which is 0. So what's the meaning of rewind? If I am reading the file like this and reach here and make rewind for my file pointer, for example, sfbtr, this meaning the position for the pointer will be not at 4. Now I rewind them to 0. Then return the pointer to 0 offset. This is a flow chart for reading records from the sequential file. So to reading records from sequential file, you need to open the file. Of course, to open the file, first you need to define file pointer. Then open or fopen for the file, for example, btr, for the file, you have to give the file name, then the mode, which is R because we are reading, equal btr. Okay, then file exists or not exist. If file exists, then you can start reading. So you will ask here question, file failed to open? If yes, then we could not open the file. If no, we did not fail to open the file, then we can start read. So we will read first record using what? Using if scan if and read first record. Then we will ask, we reach the end of the file? If yes, close the file. If no, then we will print the data and read next record and return. In the file, yes, close. No, display the data and read next record, and so on. So we will write a program for this one. This is a program. We define pointer here. For the file, we open the file for reading. Then if it return null, then we cannot open the file. Else, we have variable to get. It's like the bucket or something to get the data from the file. So we need variables. Here what I meaning for writing and reading, you should know the structure of the file. Because here you define that in the reading, you define the record. It should have number, name, and balance. But C language sees the file as sequence of byte. You use this structure and build this structure. So another one cannot write a program to read information from the file if he don't know the structure. Just said, okay, I need first record. C language will not understand what he mean by first record. But if he said, I need to read data account, then name, then balance, and account from type integer, then name from type string, then balance from type double, then he can read the record. Okay, so first we need variables to get the data from the file, then this one only to print the header here, okay, of the table. So printing anything, okay, account name, balance, it doesn't relate it to the content of the file. Here we read data from the file. If scan, then the name of the pointer for the file and the data. Here we mentioned that we have account number from type from type integer, and Y29S because the string student here size 30, and we know that we have one character for the end of the string, so it will become 29. So here we define the length of the string, which is 29 character if we minus the end of the string. Okay, so we mentioned that the type of the data here, string, so number, string, and LF means double data. Okay, so here read, this one, read first record. Okay, after reading first record, you see this one, end of the file, SFBTR. Now we taking the character of the end of the file from the file, not from the screen. So this means keep doing these things until we reach the end of the file. So if we did not, this means not, if we did not found the end of the file of our file, continue printing the data in the screen. Which data? This printf, print in the screen, yes. Which data? Data that I read it here from the file. In this variable, I print the variable. Then read another time the next record until we reach end of the file. Why we read first record, then we repeat it like this? Because when we reach the end of the file, we don't want to print it in the screen. So imagine first record like this. We read first record here in the while, and it's the end of the file. Then it will be printed on the screen and you will have problem. That's why first record we read it outside the while. Then we check in the while. If this readed record, even first record, end of the file, then we're going to close. But if not end of the file, we will print it and read next record. And check at end of the file or not, and read print until reach the end of the file. So let's read our data. Okay, I mistakenly pressed this. Okay, now we have only this record inside the clients.data. So we will read this using our code here. Okay, we have accounts 600 GG and 555. Let change the data. Okay, we have 300 Ali 4,000, and we have 100 Nihad and 44, and we have 200 and Omar and 500, and then end of the file. So we updated the data here. In this client data, we already write a new data. Let's print the data in the screen. Okay, so this only print in the screen. First, we read data from the file using fscanf. Then we check if the data not end of the file, print it, and read next record. Check if the next record not null, also not the end of the file, then print it, read next record, and so on. Then close the file. This happens like this. When you open the file, okay, you open the file and you already here defined variables. Okay, so we defined variable at the beginning empty, and we open the file. If you open the file, the pointer will point it to the byte 0, and it will not understand that it's records like this, C language. You, as a programmer, you should know that first part from the record will be number, second part will be string from size 30, remove the end of the string, then it's 29, and you should know that this one will be double. Okay, to read record by record, you as a programmer, you should define the record structure. Then after first scanf, we are reading first data and first record, put it in the variables, and the pointer will move to the next record. Then, okay, put this one and pointer 200, blah, blah, and the pointer will move to the next record. Then until after fifth scan, the pointer will reach the end of the file, depending, because we have 1, 2, 3, 4, 5. So when you reach fifth scan, you will reach the end of the file, then you are finishing. Okay, we still have only one example, then we will finish, inshallah, our lecture. Let's continue 10 minutes and then we can finish early, inshallah, today. Okay, in this example, okay, we have a client file. This client file have data for clients. We will open this file for reading. Then we will display a menu for the user to request which operation he wants. Let's see the file. The file will be like this. This one. It's have the client's information, ID or client account, then account number, name, then balance. Okay, then account number, name, and balance. Okay, what we give here, we give 3 choices for the user. If we if he want to list or print account with 0 balance, or if he want to print account with credit balance or with debit balance. So every time we will read the accounts and check if it's 0 or credit or debit, depending on the choice of the user. So here it's just like any menu in any program that we write before, and we will get the request or the option from the user, which option, 1 or 2 or 3 or 4, which is the exit. Then according to this request, we will have switch case for his request. Switch case statement. Case 1, then we will print only the 0 balance account. If case 2, then we printing the credit. Case 3, then we printed the debit. So we have while loop to continue asking the user what he need until he press 4. This mean 4, this mean exit. So we continue give choices for the user until he press exit. Okay. What we will do, we need to read information from this one. We know that the information or the record will be the account number. So we define variable to read the account number, and we have balance. So we have double variable from type double to read the balance, and variable from type string to read the name. Then we read information from the file. First record from the file. Okay, to read from the file, we use scanf. We speak about sequential file here. Inshallah, next week we will speak about random access file. So from this file, we want to read this information like previous, okay? Same like previous example. We read first record, and depending on switch case, which is the choice from the menu, what he need? He need first case, then print 0 balance. So we will print on the screen account with 0 balance, then it's same sentence here. Print in the screen account with 0 balance, case 1. So this one, case 1. Case 1 until here. This all case 1. If the user need account with 0 balance. Of course, we will check. While we did not reach the end of the file, what we will do, we will check if the balance equals 0, we will print the data. If not, then read next record. And we will repeat until we reach the end of the file. Read record, check the balance, 0, we will print on the screen. Not 0, read next next one until. After finish this case, and we already have in the file, it's opened already, we did not close it yet. So the position pointer will be at the end, yes, here. So if the user next time choose he need balance with a credit or with 0, it will not print anything. Why? Because the position at the end of the file. So to read the file another time, we will make what? Rewind. Rewind. This finish of case 3, this case 2. So he choose case 1, we print all the 0 balance inside the file. After finish, we reach the end of the file. So the position will be at the end of the file. So before doing anything else, we will make rewind. What's the meaning of rewind? This meaning the position pointer will return at the beginning of the file. So rewind the position pointer here. Okay, good. Then ask the user, he want to have another request? Yes, for example, yes, I need to check user with credit balance. So which case? Case 2. So this one, case 2. If he choose from the menu number 2, this means case 2. What will do for case 2? We will print account with credit balance. Same idea until we did not reach the end of the file. Okay. If the balance less than 0, we will print the balance. This means credit balance. Okay. Read another one and so on. Read another one and so on. If the balance 0, then less than 0, then print it. At the end, the position button, the position pointer will be here. We rewind it and ask him another time. If in the third time he used, for example, he asked for case 3, then we are printing debit balance, same idea. We check if the balance more than 0, then it's debit, we printed it, then we keep printing and scan until we reach the end of the file. After finish everything, so he choose 4, this means exit, then this is the end of the while. This while, I mean, first while, which is the request one. This means finish the menu, finish everything. So end of run, we will close the file. Let's run this code and see how it's work. Okay, this is the code. So we have menu. We ask for what's the choice from the menu. If that choice 0, 4, then we finish in the program. If that choice not 4, then we need variables to get the data from the file. Then we read the first record and we check what the choice from the user. If case 1, this means he want 0 balance, we will print it. If case 2, then balance less than 0. If case 3, then we are printing balance more than 0. Every time we finish the switch case statement, we will reach the end of the file. Every time we are reaching the end of the file, so every time we have to make rewind to return at the beginning of the file, and then we can read another time. If we did not make rewind, then we will not found anything next time we read from the file. So now we have data. We will run the program. Okay, what do you want? For example, I need a list for account with credit. Then I choose 2. Okay, with 0 balance, I will choose 1. Okay, with debit, I will choose 3. If I want to exit, I will choose 4. Okay, see here what happened. After first one, I also can print data. And why? Because after each run, we rewind the cursor or the pointer at the beginning of the file. What about if we forget to rewind? If you don't have rewind like this, then first run you will have data. After that you will not have data because you already at the end of the file. For example, I will choose same thing. I will choose 2, which is the credit. I will choose 1 to read the 0 balance. Account with 0 balance, there is no account. Account with debit balance, there is no account. Why? Because we did not return the pointer at the beginning of the file. And we know that sequential access file use position pointer and always start from the beginning. Okay. Okay. Continue. Last thing I want to mention, then we will finish this lecture, inshallah. Reading data from sequential file and writing data have problem, especially if I want to change or modify some data. You always have risk to destroy some content of the file when you are trying to modify data. So you cannot modify data without risk of destroying other data. For example, fields have different size. If you have, even if it's from the same data type, for example, if you have field from data type integer, you could have 1, you could have 34, you could have minus 890, all of this integer, but they have different size on the hard disk. We speak about store data in the files. This means in the hard disk or in the pen drive disk. Okay. So this one 1 digit, but this one 2 digits. This one 4 digits with the sign here. So when you try to modify and you have different size and you want to modify data, you will get a problem and you can destroy other data. This with sequential access file. In random access file, we don't have this problem because all the data in the random access file have the same size. We will see what's this meaning, inshallah, next lecture, but let's take example what I mean by destroying the data. If you have file like this, have this record. Okay, we have account number, we have name, we have credit or debit balance, something like this. Okay, we have some data like this in our file, and we want to change the name from white to I could not pronounce this. Let's read it like Washington or something like this. Worthington or Worthington. Okay, we want to change the name from this one to this one. Okay, to change the name, we want to write this what data we want to write on the old data. We will write 300, then the name, then the balance. So we want to only to change this part, okay? But to change this part, we will write first part on over the old data. When we write this one, okay, we write first digit, second digit, third space, fourth digit over this one. Okay, it become here. Then O over the H, it become here. Then R over the I, it become like this. Then T over T, it become like this. H over E, it become like this. I over this space, so this space become I. N over this 0, so this 0 become N. G over this comma and so on, until you reach 0 over this G, so it become like this. So our data was like this, and I want only to change the name, but data become like this. So we lost this part of data. Why we lose this part of data? Because white here 5 characters and Worthington here 10 characters. So in sequential file, always modifying data, you will have risk for destroying other data. You overwrite the name, but you destroyed other parts of data. Okay, that's all for today. See you inshallah next week. And happy Eid for all of you. Happy Eid for all of you, and inshallah after Eid we will meet inshallah again with the second part of files, which is random access files. So after Eid, inshallah, we will take random access file. Eid Mubarak and happy Eid for all of you. Assalamu alaikum wa rahmatullah.